These are the two big paradigms, right? New IT, no IT. No IT is all cloud. Now, this is an either or question. Either it should be hardware defined or software defined. Right? Now, what is happening, right? To make it simpler, when everything is in hardware, the way we used to traditionally do it, everything is by a good vendor. Our friends at Cisco, Juniper, all of these guys are great guys. I mean, I have no problem with them. We have enjoyed their services for the last 20 years. But the fact is, cloud changes everything. What is happening now? Going up. Everything is getting software defined. Because now you can automate, you can orchestrate, you can create topologies for specific to your application and deploy it anywhere. This is the reality of the world. Now how do you do it? Can you do it with the old hardware defined mentality? There's nothing wrong, you can still do it. That's what Cisco tells you. AP, what is that?
Epic.
What is that?
Epic.
Epic.
No.
Network program.
No. What is that? Cisco's orchestration platform.
Oh, UCS. UCSR.
NSO and what is the other one? API.
Epic.
APIC, right?
Yeah.
So there's these two frameworks that Cisco says, you know what? You can actually orchestrate your application end to end using Network Service Orchestrator and APIC, which runs on Nexus 5. It's all hardware defined. It's possible. Now the other approach is software defined. vRealize automation, NSX. This is the world VMware comes. I come from that world, so I'll be a little bit biased. So just bear with me. Now, why is that world very well understood, right? So if you had the previous world of servers, how we used to run applications in the past, we used to do everything. Earlier, you used to have RISC environments where the vendor that used to supply mainframe, RISC, mini computers, everything were, the stacks were owned by the particular vendor. Come virtualization, what happened? All of these activities, you can programmatically create snapshots, programmatically do a lot of things once virtualization comes in, right? Now, the intelligence has gone from physical hardware to virtual layers. This is the progression. Now, with data center virtualization, now you are able to have a completely more evolved operational model for your data center. You can see virtual machines, virtual storage, all of these activities are much more easier to do. They're all simplified by pooling the compute, pooling the storage, pooling the network resources. You're able to build infrastructures that are very, very flexible, very, very agile, very, very secure in a very easy manner. Now, that was traditional virtualization. Traditional virtualization was primarily around compute, CPU and memory. You still had the problem of change management with storage, change management with network. You can spin up a VM in 5 minutes, but if you want to make it part of a 3-tier architecture, make it part of a mission critical application, you still have to have network rules, you still have to have storage policies, you still have to have provisioning of storage. All of these things used to still take 1 week. No fun of VM, right? Now, come cloud providers, what they have done, they have created these things as infrastructure layers over common off-the-shelf software, the compute, storage and network pieces. And then they have built custom platforms for orchestration, automation and application deployment. This is how our Googles of the world, Facebooks of the world, all these cloud scale environments have been built. So now you have two directions to go, right? You still want to do this programmability, ease of deployment in your own environment. What are the two ways you can do it? You can either go the hardware route where you can still rely on APIC, NSO, Cisco and run your application in an orchestrated manner. Nothing wrong, this works. But there is a better way. That's the better way. Here, you do almost like the Google guys, where the SDDC platform itself is kind of built for you by VMware, and now you use those APIs and capabilities and UIs to actually create an automated, orchestrated environment. Now, the key thing is whether it is a software-defined data center that is sitting on your premises or a hybrid data center that runs on a VMware-based cloud, for example, VMware on AWS or IBM's SoftLayer cloud or any vCAN provider like Savvis, OVH, all of these are completely based on SDDC stack. Now, when they're based on SDDC stack, any policies, any IP that you create on your premises can directly be applied in that premises on the cloud, which is a big advantage, and that's the reason why the AWS on VMware, VMware on AWS is a major announcement, because now every CIO can do that checkbox very easily, the cloud checkbox, which their CEO wants.
So what happens to the compute? Because
doesn't matter.
But so I still didn't get that. So we were originally our infrastructure, everything was VM, traditional most of it. So the compute, storage, everything that was of VMware, when you are migrating to the cloud, what will happen? Will they provide the compute on AWS environment, or will it be on the same VMware environment that we had?
Your VMDK will work unchanged.
On which environment?
On AWS. Yeah. So we'll talk about. I'll answer it more detailed in the 5-minute break.
So
let me just go on.
Question
So-
item.
Yeah.
Yeah.
Well,
Please.
please.
Yeah. So I have mine. And now let's try and understand in the environment that we talked about. The key thing is the commonness of policy management for the network. So now I'm going to go deeper into the network virtualization. The next few slides, we are going to go deeper into what is that big change of software-defined networking. How is it very different from having a virtual switch? In traditional VMware environments, networking is only layer 2. We're only talking about layer 2 services. Traditional networking, till NSX came into the picture, there was a product called DCNS which did some firewalling and things like that, but that was very minimal. There was more from a security and networking standpoint. It was not very popular. So now with NSX, we are moving from just layer 2 all the way till layer 7. Now, how do we do that transformation is next few slides. So let's try and understand network virtualization. Traditional networking, you have all these routers, switches, and then you had these. How was a traditional network laid out? You had a core network, which had got all these WAN, routing, gateway, firewall, these type of services. You have an aggregation layer, which is primarily layer 2, layer 3 combination. And then you had an access layer, which is primarily layer 2. That was the core. Now, come cloud, all of those layers are gone. Juniper and some Arista, all of these guys completely badmouth that 3-layer architecture. Today even Cisco says, okay, you badmouth it, it's okay. Now we'll also come to the new age. The new age is only 2 layers. Spine, leaf.
Yeah.
Spine, leaf. That's it. All leaves talk to all spines. It's a very simple architecture. Right? Now, for NSX, that's a very good thing, because we consider that as an underlay network. We just need the basic connectivity. All the higher order services, we want to do it in virtual. So that's what we are going to learn next. So now if you look at the traditional compute, the traditional network used to be mapped to traditional compute. Access networks used to be top of the rack. Every rack used to have an access network that is top of the rack. And these top of the rack networks used to go to an aggregation layer, and then they used to go to the core. Right? So now from here, if you look at the transformation, you used to have virtual switches which are mapped to the real switches. That was the old style of doing networking in virtualization. Remember, all of that is still,
Valid.
no, all of that is still which layer? Layer 2. Everybody with me, right?
Yeah.
The traditional networking in virtualization was layer 2 because all these top of the rack switches were layer 2. So now from layer 2, where do we go?
Don't keep saying traditional, Ram.
Anyway, that's like 10 years back. That's still traditional. So anyway, so now think of what was hypervisor doing for the physical hardware? It was abstracting and pooling the physical hardware. From the perspective of CPU and memory. The job of a virtualization layer was abstraction and pooling of compute and memory on a physical hardware. That was the goal. Right? Now, network hypervisor does the same thing for the network resources. It does abstraction and pooling of network resources that are in the underlying network. So that you can build flexible, scalable, simple, automated, programmable infrastructure on top of the network hypervisor. That's the beauty of NSX.
How is it different from, of course, questions later, right? Please.
Yeah, lots of questions. Can't ask them, but.
The VSPF
No,
clusters.
just write it down. I will answer. I promise. So now, if you look at this, what are we doing? We are creating virtual networks, virtual boundaries between VMs, interactions between VMs, programmatic interactions between VMs, all as virtual networks. And suddenly, some of the physical network boundaries and physical network limitations are gone. What are the physical network limitations? You all know VLANs? How many of you know VLANs? Raise your hands. Okay. What is a VLAN?
Virtual.
What does it do? I mean, how do you represent a VLAN?
It's
Broadcast domain, limit the broadcast domain.
Limit the. Where is it? Like, where is that intention of a broadcast domain actually executed? In each switch,
Yeah.
right?
Yes.
How does the switch know?
You configure.
Oh, you configure it. Very good. Good. So how does the configuration identify a VLAN?
VLAN ID.
VLAN ID. Where is a VLAN ID?
inside the switch.
Inside the Ethernet frame. Inside the tag control identifier. There is a small field. That field has got an ID. Every frame is coming with frames. Ethernet. Remember, 7-layer model. Frames, packets, routing, all that. Layer 2 is frames.
Right.
Data.
Right?
Right.
Yeah. In the Ethernet frame, there is something called a tag control identifier.
Right.
And then in that tag control identifier, there is a VLAN ID.
Right.
There is a class of service. And there are some other things you don't want to know. It's too deep. Good. So the key thing is that ID can only take 4096 value because that is only that many bits.
Yeah.
Problem. In cloud, you can have that many more tenants and 4096. So you needed a big address space, big canvas. So this virtual networks, they have millions of networks you can create like this. The virtual network VNIs that you create in NSX, you can have millions of them.
So V6 is important.
Oh, it's not V6. It's not even V6. It's layer 2.
Oh, it's still there.
You're saying layer 2, is it the sine leaf or is it
No, the OSM model, right?
OSM
The
model?
OSA model, like, it is still layer 2. We are not even going, it's frame level.
So how do you do that?
Oh, it is because that whatever virtual network you are creating, you are putting a MAC in a MAC. You have a MAC address in one frame, and then you have another frame that is like a wrapper frame. That frame also has got an ID, and that ID is big.
That ID is 48-bit.
Oh, that ID much bigger.
Oh, okay.
We'll talk. That is deeper. Not now. Right? So you get the picture, right? So now, how does the interaction happen? all the underlying network is just a bunch of wires for us. Everything else is happening on the overlay network. You're creating virtual routers, virtual firewalls, virtual load balancers, virtual everything in the virtual domain. Now, doing that, now when I do it in virtual domain, where exactly do I apply the policies?
In the domain, virtual domain.
Very good. That means where? That means in the kernel of the hypervisor. So all of this is happening inside the kernel of the hypervisor.
So no job.
So anyway,
Finish. My
You're out of
question
work
was
now.
the next certification. It looks like CISSP has rolled out.
So,
So-
what is that kernel? What is the Linux?
And no
What
questions.
is built
No
on?
questions. I have
Python
software.
12.
we'll talk. We'll talk.
I don't think so.
So now, because all of this is defined in software and programmable, you need to have some sort of management platform there where you are setting your intention up. You are actually defining, hey, what should be my policies? Which VM should talk to which VM? What kind of firewall policy should be there? What kind of load balancing policy should there? You can actually define in software and then apply. This is what in VMware world we call it vRealize automation, and that's the area where I work. So now, how does it all get panned out? There is something called an NSX controller. There's an NSX manager, and there are 3 NSX controllers, and then each of the ESXi hosts gets the actual configuration of how it should react to each packet from the NSX controller. So there is something called user world agents. I don't want to go into too much of detail. For now, you understand that the NSX controller guy is actually telling each hypervisor to do what it has to do. And who is telling the NSX controller? NSX manager. That's where you are defining how your topology should be. Right?
Right.
So there is like a 3-layer hierarchy, and again, you are creating a policy. You are saying this is where you are creating an intent and understanding the impact at the management layer. You are actually doing the sensing and acting as a controller, and basically sensing and analyzing in the controller layer and acting in the hypervisor itself. So think of it like this, right? Intention, sensing, acting. Right? So sense and analyze. So this whole thing, it is all defined in an abstract way in software. That is the beauty of this approach. Next. So the distributed network services, who is governing the distributed network services? Now if you see this picture, that's how it happens. The cloud management platform, the NSX manager tells the controller, and the controller will go and tell each NSX vSwitch that is inside the hypervisor to do what it's supposed to do.
And that vSwitch talks to each hypervisor again?
Think of it like that. The way NSX works is every interaction that's happening at the VM is being analyzed of what should be applied. Whatever that interaction has to be applied to policies wise, they are applied all the way at the hypervisor layer itself.
Okay.
That's it. It's easier to understand that way. Now, that the packet flow goes like that all the way to the next VM.
Yes. Cool.
Right? So, first, logically it is flowing like that, but physically it is flowing like that. Is it clear? Now, how do I create multi-tier networks? This is the last time we talked about this, right? Now it's very easy. All I'm saying is, this fellow will talk to this fellow will talk to this fellow, everything I write it in software and say, psh. When I push it, everything works. That's the beauty of this. Now, why is this so useful, right? Earlier, if you had to do the same thing, you had to go through those hairpins all the way to top and come back. Now with NSX, no hairpin. Right there. You're just going. You're not going all the way to the core and coming back. This is a very, very important thing. This is all what is called east-west traffic. You are making the east-west traffic more effective. Right?
So what is it called? It was hairpin here.
So, see this.
Yeah, I see that. Yeah, hairpin. Now.
No hairpin. Because everything is being applied here at the hypervisor. Remember, firewall rules are applying at the hypervisor level.
Okay. The two wire forms.
Yeah. So the operational model of the VMs also changes a lot. Now you can do a faithful reproduction of L2 and L3 services in the overlay. You can run across existing network hardware without any changes. You can do distributed routing, switching, firewalling, everything. And you can do service insertion. This is another beautiful thing. We'll talk about a service insertion example. For example, application-based new generation firewalls like Palo Alto, how do you insert it in the same flow? We'll talk about that use case.
Cool.
This is the new normal. This is the new normal. This is how it runs. So now, 5-minute questions.
Okay.
We have
now,
100
first question.
Yeah, good.
Where is the mapping happening between the sign and leaf to the OSI layer?
So we don't even do that. See, for us, we don't care.
Really?
Yeah. The underlying network is underlying network. For me, it's a 10 gig connection
No, but
between
you're
two.
going to call those layers.
I don't call.
No, the program has to call something.
No, we don't call. It's an overlay network.
It's
That's
all
it.
finished. That's what it is. That's why the whole.
It may not be available to me, but it's getting translated.
It is
It's
getting, true sir, true ma'am.
getting translated.
This spine and leaf model is already connected, everything to everything.
Yeah.
Yeah.
So physically it is connected already,
Yeah, I'm trying to
right?
understand.
You are sitting on top of it and using that as a wire from between
Yeah,
one
but
point
the
to another.
sign map to which layers of the OSI?
So the spine and leaf network is still a layer 2 network. It's still a layer 2 network.
What about the leaf?
Leaves and spines are connected at layer 2. The services infrastructure for spine and leaf networks can be defined separately, and that's a different topic. Software defined networking in itself, open flow controllers, talking about open flow controllers, creating network architectures on top of spine and leaf. That's a different topic in itself.
Moreover, Ram, I think you should say that that's not for the traditional data centers. The modern ones are using the SDN, are using Spine.
So I will have to make it little bit easier for you to understand. So in a traditional, if you want to integrate a physical network switch into a virtual network switch, you can still do it. The control protocol that VMware still uses VXLAN. It doesn't use the OpenFlow in its original standard. It is all proprietary technical. The NSX controllers talking to the ESX hosts, or the NSX controllers talking to NSX managers, these are all happening on VMware's own terms. In a true software defined network, those conversations happen over OpenFlow between the control plane and the data plane. The whole disaggregation of control plane and data plane is what brought about this whole revolution of software defined networking. Yeah, that's a good question. But in case of VMware environments, it makes it really simple. We really don't care. We consider it is as a simple wire for me. We really don't care about what services are running also.
No, we don't. Yeah.
Yeah.
We don't care.
Yeah.
Now, do you want to elaborate what protocols you use on the SDN level in NSX? VXLAN or why?
Yeah. So
Almost to understand.
yeah, that's a good question. Actually, VXLAN is a protocol that was originally it was a gift of Cisco to VMware. It's actually a very heartwarming story. You know, Cisco was one of the biggest investors of VMware before EMC bought it. It's a really sad story how they became biggest competitors to each other, and especially after Dell buying it out, it's a very different equation. But if any two vendors, if you want to see the camaraderie between any two vendors, prior to Nicira's acquisition, Cisco and VMware were like that. some of the best things, best capabilities of VMware networking were actually friendly gifts of Cisco. You know, VMware vSwitch behaves like a Cisco Catalyst switch, literally.
Very close.
It literally appears. You can actually do a Cisco Discovery Protocol on a VMware switch. And VXLAN was a protocol for inter-VM connectivity at layer 2 that was jointly defined by VMware and Cisco. Cisco being the big brother, by the way.
Now everybody is using this thing.
So now everybody, it's become the world's protocol. But unfortunately, I mean, we can go into
Plus, 4,000 to how it went up to 16 million.
So that
will clarify some of these guys.
yeah. So the whole idea of Mac in Mac. Why don't you tell? You are the guru.
No, go for it.
Go for it.
See, next.
Yeah. Yeah. So the idea of having a frame inside a frame, Ethernet frame inside an Ethernet frame, was purely a VXLAN idea. So the whole VXLAN protocol, because there was a frame inside a frame, Mac in Mac, this approach of Mac in Mac, there were a couple of industry standard protocols that were being built by one great lady called Radia Perlman, who also is a definer of, you know Radia Perlman, right?
Yeah, I remember what,
Spanning tree, the same lady.
pardon me?
Spanning tree protocol. Spanning tree.
Spanning tree, oh.
Yeah, the same lady. So she was instrumental in building a protocol called Trill. Trill is transparent interconnection of lot of links or whatever. So that protocol had a similar approach, and VXLAN had a similar approach. There are a couple of other protocols that allowed you to scale beyond the limitations of 4,000. And because VXLAN had this capability, when Nicira was bought by VMware, it was one of the mandates not to go for the OpenFlow and go for VXLAN by VMware, because in fact it's a very, I mean, at least my reading, you can take it for what it is worth. My reading of the Nicira acquisition was it was a defensive acquisition. What was happening was the OpenFlow, the OpenStack Open vSwitch that was published by Nicira was so very clean and good that it started the massive adoption of OpenStack in enterprise, which threatened VMware. And overnight they bought Nicira for $1.2 billion, and they kind of muted the Open vSwitch. This is my understanding. I mean, take it for what it is worth.
So
I mean,
you still
I'm
did not answer the 4096.
So because this Mac in Mac approach, you can actually create a much bigger header in the second.
It's like an address.
So
Yes, you actually create a bigger address space in the outer envelope. That's
so
all.
what is the maximum size? Or it's a 2 to the power. So you use
There are versions of VXLAN. We'll talk about that little later. It'll just confuse everybody if I because there are a couple of versions. There is more complexity to it than in this forum. Okay.
So what are the limitations of NSX? You know,
I will talk about that towards the
talk
end.
about that.
Right, like I think what you guys are talking about now, at the physical, the old school, physical way of doing
Right.
things,
Right.
there's a limitation on the number of hosts you can have per network.
Or number of VLANs that you can have in
Or a
a
number
network.
of VLANs that you can have. Now,
Right.
do those limitations disappear in the virtual?
That limitations become much larger, which kind of
Still
make-
limitations, but larger.
Right.
Okay.
That's all.
So,
Maybe you can.
what happened to vBlock? You know, VMware had challenges with it, so what happened to vBlock?
So VC got disbanded. In fact, VC was completely bought over by EMC. Now VC talks about composable architecture, VxRail, and it kind of changed the whole strategy.
With the whole world moving to containers, I see this NSX is pretty good. I don't get it fully though. it's still focusing on VMs.
You will get it in the next few slides. You will get it.
No, no.
And with containers, it's even more relevant. Actually, it makes it easier to do container-based infrastructure.
So actually, if I were to see this, it is, so we are using vSphere, this is vSphere 6.
Correct.
So in our case, the optimal range was decided was for a cluster no more than 20 VMs, because that was the load it could
Oh,
take.
now that limitation is not there. We'll talk about that.
So, but now if I see you, you are more like Mesos or what I see you. Am I correct with that?
No, those are completely different layers of abstraction, where mesos and all of them are clustered up. We are talking about network interactions only with NSX.
But then you, because of your VLANs and all, I see you now as a single converged thing, the whole data center.
Now, give me a few minutes.
Okay.
In the next 5 minutes,
I
block
thought
will
we're
done.
done.
Yeah.
Let's keep going.
Oh no, this is only the midway.
It's the Mahabharata. One episode is there.
One episode is there. Yeah, Mahabharata second episode.
I like that.
There are many episodes.
So, we need 25 days of
Different version to this.
So the traditional networks, you have a standard perimeter and you do everything at the perimeter. Now, with the new type of threats, WannaCry,